previously it may be confusing. What's about 24 with this table?
I got E.
Okay, and tell me please your reasoning. So how you solved it, if you remember.
From any individual judge. So let's say if Adam got let's say 1 the next round.
So did you complete this table? Because the part of the problem was that you will use the condition that is written here, and you will actually fill out this table with numbers. Did you put some numbers here? Because once again, it's very interesting that no two competitors get the same mark from any individual judge. No two competitors. So there are competitors. Where are competitors and where are judges? Can you tell me?
Hmm?
5 competitors. 5 competitors.
Yeah, Adam. Yeah. The
3
judges
judges
are,
here. Okay. No
yeah.
two competitors get the same mark from any individual judge. Okay. What does it mean?
Like they can't get the same mark as someone else from the same judge.
Yes. So, for example, yeah, here all this should be different. But can you tell me how you solved it? So, did you fill this table with any numbers?
So well, I just canceled out 3 first. Like D like cancel because if like Berta needs 3 from the third judge to get the sum 5.
Mm-hmm.
So I put 3 on
Mm-hmm.
in Berta's.
Yes, great. Okay, so it is our first step.
So that means it's not D.
Okay.
Um and um I know that it's not 2 for in Adam because Berta got 2.
Yes, exactly.
And
So,
it's also not 0.
mm-hmm.
So
Okay.
that means it's 1, 3, or 4.
Okay. Yeah.
Um, I just put like a holder in to
Okay.
get. I put 1 in and Adam's judge number 2 and 4 in, and
So
it.
you decided to like jump straight to this column, but maybe it's because as you can see there are way too many options here. So there may be like 1, 2, 3, and so on. What can you tell about Clara? Usually this table just is completed step by step in here. And
Clara,
yeah,
I would say it's since it's not 2 or 0 on the top one,
yeah,
and she only has 3.
yeah.
I I'd put like it could be 1 from judge 1 and then 2 from judge 3.
Exactly, and this is the only option. There is nothing else that that can be here. It's the only option for Clara from judge 1 to have
Yeah.
1, and it means that from the last judge, from judge number 3, she has 2. Okay, so for Clara, everything works out. Okay, so what?
I mean, for number 3, for Adam, it's either 0, 1, or 4.
Mm-hmm. Okay.
And the number 2 for Adam is either 1, 3, 0, no, 1, 3, or 4.
Yeah, as you can see, we are still not sure about Adam. It means that we cannot yet conclude and give like final answer. Maybe we look to the other one, to David. As you can see, many rows are here already well known. For example, in the first row, David cannot have either 1, 0, or 2. It means that in the first row, David may have what kind of mark?
3 or 4.
3 or 4. But once again, let's assume
Okay,
that
so 3.
yes, if he has 4, it means that in this row, in the second, it should have 0, and it
3,
will have
1, and 0.
3. Okay, so 1 and 0. And how can we understand that 1 here and 0 here, or 0 here and 1 here? So yeah, absolutely correct. You probably know the answer. So I will.
And then
Yep. Okay.
Emil It
Yeah.
has to be 4 for the first one.
Okay, great. 4 for the first one. Okay, and what for the second row?
Either 3 or 4.
Okay, 3 or 4. Well, it's 3, 4 here or 4, 3 here.
It's
What
3, 4.
3,
Because
4? Yeah.
yeah,
Why?
just already. Judge 3 already gave 3 to Berta.
Great, great, perfect. So this one is finished, and now I think that as we know almost all the table, we can understand what Adam has, because once again,
2, 4, 1.
2, 4, 1. Yes, exactly. So now we understand, right? Because now we don't have many options. We have only one option for Adam here and here. But what we needed to do, we just needed to follow like the basic logic here. We just filled all our table, filled all the columns, and after that we eventually came to the first column and we put all the numbers to Adam. As you can see, in this kind of problems, and especially in the future when you do geometry, you shouldn't really focus too much on what they ask you. You just step by step find everything you can find, and after that you will come to the solution. That's what we did here. Yeah, we just completed the table, and after that we found what is the mark for the atom. Perfect, perfect. So what's for 25?
25, I got E. I don't know if I'm right though.
Okay, so just a second. Product of numbers to edges method vertex. Just a second. I will copy and paste it. So he writes a positive integer on each edge of the square. It means that we have a square here. Okay, integer. So did you mark these integers somehow? Because they are obviously unknown for you. Did you mark them like some variables, maybe x, y, or a, b? How you denoted these integers? It's a very common thing. If you don't know the integers in mathematics or some values, usually you mark them as a, b, c, d, something like this. A, b, c, d, because writes a positive integer on each edge of the square. That's what we did. We don't know these integers, but nevertheless, she also writes at each vertex the products of the numbers on two edges that meet at this vertex. So what should I write here at this vertex? Which number should I write here?
AB,
AB, great. And which number should I write here?
BC,
BC, and here?
AD,
AD, and the last one?
DC,
DC, great. And what we know? We know that the sum of the number at vertices is 15. We can write like AB plus BC plus AD plus DC equals 15. What is the sum of numbers on the edges of the square? It means that we need to find is A plus B plus C plus D. That's what we need to find. Of course, we should use here that these are not just any numbers, but these are integer numbers, right? Positive integer numbers like A, B, C, D. So let's look at this equality. Do you have any ideas how to find numbers A, B, C, D?
um,
Well, you have this one,
well,
AB.
yeah, so,
Well, for example, usually when we kind of, when we simplify expressions, do you understand that, for example, if I write AB plus BC, I can put B out of the parentheses and I can write it like this.
yeah.
Yeah, so it's a very common thing. Well, if we do it here, we can simplify it like greatly. For example, instead of this first sum AB plus BC, what should I write?
For BC,
B, and what's AB plus
A
BC?
plus C,
A plus C, okay, and here, the next two, AD plus DC. What should I write here?
D,
D,
parentheses, A plus C.
great. And all of that equals 15. Is there a common factor here, like B times A plus C and D times A plus C? Is there something common here?
A plus C.
Okay, and how can we write it? Can we write it like A plus C, and inside the parentheses will be B plus D? Can we write it this way? Because
Yeah.
a plus c is just like a separate number. It's like separate variable, so we can take it from here and we can represent it as a plus c multiplied at first by b and a plus c multiplied second by d. Do you understand this, what we did here? It's just nothing complicated.
Yeah.
Okay, so, but now you have this expression in a very simple form. A, C, B, D, all of these are integer, like positive numbers. For example, A is 1, C is 2, B is 3, D is 4, something like this. And what you have here, you have this number, which is obviously like positive integer, times this number equals 15. Are there many options that you can multiply two positive numbers, integers, and get 15? Are there so many options?
No.
So what are the options for A, C, and BD? For example, A plus C, the first factor,
It could be five.
it can be 5, great, okay, and B plus D can be
10.
10, because 5 times 10 is 50.
Mm-hmm.
Well, if this
But
one...
10. Oh, multiply 3.
3, okay, 3. So do you understand the reasoning? We just simplify this expression. We kind of rewrote it in this form. And after that we say, this is a factor and this is a factor. The product of two numbers is 15. It means, for example, that this option will work for us. One number is 5 and the other is 3. And tell me, please, about A and C. The sum of some numbers A and C is 5. What can these numbers be? Like 5, maybe 5 and 0, 4 and 1. What are your options?
5, 0, 4, 1, 3, and 2. And
I'm just asking you because I want you to pay attention on that we have a positive integer on each edge of the square. It means that A, C are positive integers. So none of them can be 0, right?
yeah.
So tell me your options about these numbers. A, C, B,
So
D. Yep.
A could be 4,
4.
3, or 2, or 1.
Okay, yeah. So just you can tell me any options, any variants.
4.
4 and C is
1.
1 and B is
2.
2
And D is 1.
Is 1. And we are asked what are the sum of these numbers on the edge of the square. What is the sum of A plus C plus B plus D?
8.
8, great. So do we have this option as a correct one?
Yeah.
Yeah, we have it here. But by the way, we cannot guess at this moment. When you get this one, just a second, it was our last result. When you get this one, I just ask you to find some numbers. But in this case, basically the problem was solved. We are asked what is A plus B plus C plus D. You can just sum these equalities. You sum left side with left side and right side with the right side. And when you sum these equalities, on the left side you will have A plus C plus B plus D, and on the right side you will have 8. So it would immediately give us the same answer. Right? So there was no really need to find in particular what are these numbers. You can just sum these equalities, but nevertheless, can you tell me in your own words, just to confirm that you understand, how we solved this problem? Just briefly.
Oh, so we just simplified it until we got something where we could like put the values in. And then we just added all the values up for each variable and saw if it was an option, and yeah.
So do you understand this step? For me, it's very important that you understand this step, that how we get this expression and we turned it into this expression and then into this expression. Okay, because we group these two terms and write it as B times A plus C, and then we group these two terms and write it like this. So is everything clear? Just tell me yes and we will go to the next one. Or I can explain.
Yeah.
Okay, perfect. So what about the next one?